All right, and welcome back to e-learning. It's Friday, March 20th. So hopefully you enjoy your last day of e-learning for the week before spring break. We're going to look back at graphing exponential functions and logarithmic functions, things that we have to do here in order to graph our logarithmic functions. Those transformations or shifts, how is that function shifting, left, right, up, down, as well as the key characteristics, the domain, range, end behavior, the asymptote, the intercept. So as always, stay safe, stay healthy. But let's look at the last 3 or 4 problems here from your homework. So let's start again. Let's do the first one together, and then we will kind of break off. I'll have you guys try to graph the last 3. And you can always pause the video whenever you need to and unpause and follow along and see, how did your work go? What things do we need to review? As always, send me an email, put a comment on the Google Classroom. Let me know what type of problem do you want to see a video for, and I'll be more than happy to make that. So again, let's start off with graphing this. We'll always start with our XY table. And you can look here at, we'll always start off with just the function there up until we get to x. So whatever number we're plugging in for x, we're saying log base 2 of, some number. Let's start with 1. So we're saying 2 to what power is getting me 1? I should really change that. So 2 to what power is getting me 1? 2 to what power would get me 2? 2 to what power gets me 4? And again, we always want to do multiples of 2 or powers of 2. So 2 to what power gets me 1? Well, anything to the 0 power is going to get me 1. Doesn't matter what base you're working with. 3 to the 0 is 1, 200 to the 0 is 1, a million to the 0 power is 1. Now, 2 to the first gets me 2, 2 to the second gets me 4, 2 to the third gets me 8. And again, you can always do the fractions here. So 2 to the negative 1 gets me 1/2. 2 to the negative 2 gets me 1/4. So let's graph these, and let's make these very small dots so that we can do our transformations here in a minute. So we start with 1, 0, small dot, 2, 1, 4, 2, 8, 3, and then, 1/2, 1/4, 1/8. And now let's look at how are we going to shift this function. What transformations do we see? Now, in the parentheses here with the x, I've got a +8, which means that this must be shifted left 8. Remember, it's always the opposite of what you see there in the parentheses. And then I've also got a -4, so left 8 and down 4. There's no stretch, no compression, no flip, nothing like that. So I'm taking all these points going left 8 and down 4. So let's start here. So left 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4. Make a little bit bigger dot. Left 8, down 4, left 8, down 1, 2, 3, 4, left 8, down 4, left 8, down 4, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, and left 8, down 4. So we can kind of see here as we connect these dots that our asymptote is going to end up being here at x is -8. And again, let's kind of do our best to make a rough sketch here. It doesn't have to be perfect. You can see that's not the best, but it gets us what we need. And then we can just look at our graph here, that domain, of course. Domain is x. What is our x value restriction? So we can have any of these x values, but we can't have anything over here. So I've got x is bigger than -8, because remember our asymptote is at -8. -8. I gotta work on drawing those 8s. -8, that's pretty good. And our range, as always here, as long as y is a real number, because I'm going down forever and very, very slowly up forever. So now let's look at when is my graph going up the y-axis. So as I go left, my y values are decreasing. As I go right, the y values are increasing. So as I go right toward infinity, my y values are increasing. And then when are they decreasing? When do they approach negative infinity? Well, we saw just a second ago that as I go toward that asymptote of -8, as I go toward -8, then that y value goes down. And the x-intercept, like we saw yesterday, this is one where it's a little bit trickier. So you're looking for when is it crossing the x-axis? When is my y value? When is this axis here? 0. So when is the y-axis 0? When is my y value 0? So what we can do here is we can change it to green. We can plug in a 0 or substitute a 0 for y. So we can say, let's kind of box this off, x-intercept 0 equals log base 2 of x plus 8 minus 4. Now, let's get our log by itself. So we can add 4, log base 2 of x plus 8 is 4. And anytime I've got a logarithm set equal to a number, then what we can do is we can write this as an exponent. So base of the exponent is the base of the log. So 2 to the 4th is x plus 8. Or 16 is x plus 8, which means x must be 8. So you've got to know this really crucial step here of writing your logarithm as an exponent, identifying that anytime I have a log equal to a number, write that as an exponential form. So again, you can always pause these videos, try the next few problems, and then unpause and see how it went. Or of course, you can just follow along. That's all right as well. So next up here, we've got, let's just kind of isolate that bit right there. X, y, always start with 1, because anything to the 0 power is 1. So log base 1/3 of x equals y. So we're saying log base 1/3 of x is y. So 1/3 to what power gets me 3/1, or just 3? Well, if I flip that fraction, that means it must be a negative power. And 3 to what power gets me 3? It's 1. So we can do the same thing here. 9/1. We flip that fraction, so it must be negative. And 3 to what power is 9? It's got to be 2. And then, of course, we can do 1/3. 3 to the first power is 1/3. 3 to the second power is 1/9. So very, very helpful to know your powers of 3, powers of 2 and 4, all those sort of typical logs when we're graphing, those log bases. So we've got a shift here or a transformation there. So let's make sure to put these dots, very small dots, on our graph. So 1, 0, 2, 3, -1, 9, -2, 1/3 is 1, 1/9 is 2. So it's looking like it's kind of, doing one of these. But of course we need to shift all of our points. And how are we going to shift these? If it's inside the parentheses, we know it's opposite of what you would see there. So it's got to be right 4. So we're shifting everything right 4, which means we're going to end up shifting this asymptote right 4 over to here. And we'll see that here in a second. So we're shifting right 4. All right, so let's kind of find our dots here. So here's a dot. We'll shift 1, 2, 3, 4. Make a bigger dot. Shift 1, 2, 3, 4. Slightly bigger dot. That should be 1/3. It's pretty close. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and then this is going to go off the graph. Again, doesn't need to be spot on, just so that we can see kind of what's the trend here. What pattern do we see in our graph? Because this allows us to see that our domain, x, so as long as x is bigger than, again, we're over here, so bigger than, and then what is this x value? It's +4. And then the range, as always, real numbers, because again, here we're going up forever. Here we're kind of going right and down forever, however slowly that might be happening. Eventually we would hit negative infinity. And that comes up here in our end behavior. So when is my graph going toward the positive y values? When is it going very, very far up in those y values? Well, if we check out our graph here, I'm getting very, very big y values. Okay. These y values are getting bigger as I go left. So as I approach that asymptote of +4, I'm getting these very big y values. And then that leaves us with positive infinity. So as I keep going farther and farther to the right toward positive infinity, then I'm getting these lower y values. Where's my x-intercept? This one's kind of nice. It looks like our x-intercept is right at, if we count that, 5, 0. But we can always check that. And in fact, we will here in a second. And our asymptote, x = 4. Again, you can always check, if you're not sure, these numbers have got to match up. If they don't match up, you've got some kind of problem. Check your work again. But let's check this number. Let's check that x-intercept. And how do we check that? Well, we see our y value is 0. So let's start with red. So 0 equals, and we kind of box this off, equals log base 1/3 of x minus 4. And this is kind of nice because we've already got a log equal to a number. So we can say 1/3 to the 0 power equals x minus 4, or anything to the 0 power is 1 equals x minus 4. And if I add 4 to both sides, then sure enough, I will get 5. All right, if you want to, again, pause the video, try 6 and 7. I think a nice refresher here. You've had a chance to look at, again, how to graph some of these, so might not be a bad idea to pause the video, try these last two, see how these go, and then check back in. So let's look at our graph here. Again, we're going to graph just our parent function, log base 5 of x. So start with 1. So 5 to what power gets me 1? That's 0. 5 to what power gets me 5? That's 1. If I did 25, if I had that space, that'd be 5 to the second power. And then, of course, we can always do 1/5 is -1. Anytime you flip a fraction, you've got a negative exponent. 5 to the negative first is 1/5, because you've got to move that exponent down. And 1/25, which is, pretty close to 0 as far as graphing on this particular scale goes, is -2. So let's make some small dots, because we've got these transformations to worry about in a second. 1, 2, 3, 4, 5, 1. 25 is going to be way over here. I'm not even going to graph that one. 1/5 at -1, 1/25 at -2. So we can kind of get a trend. We can get an idea of what's going on here. Something like this. Of course, this will keep going up forever, very, very slowly. And now let's check out our transformations. What do we have to do? Well, I've got this here, this -2 inside my parentheses, which tells me I've got to do the opposite of what I think I would do. I've got to go right 2. Typically, we would think of -2 as a left movement, but again, we're thinking of what's going to make this 0. 2 minus 2 would be 0. So here we're going right 0. And down 1. Let's go with a blue-green, if I can find here's a good one. Make like the Miami Heat colors. So right 2, down 1. So let's go from these points, right 2, down 1. Right 2, down 1. We can make some bigger dots. Right 2, down 1. Right 2, down 1. And we went right 2. So we shifted that asymptote right 2. Had a very straight line here. There we go. The magic of the Apple Pencil. I just realized if you're in my Algebra 2 class, we missed Straight Line Tuesday. So I apologize for that one. We'll come back with Straight Line Tuesday after spring break. So there's my new graph. And let's check out this domain. Looks like my x values, as long as x is bigger than 2, I'm pretty good. Range y, still a real number. Now, when is my graph getting higher up my y-axis? When am I getting those big y values? Well, it looks like getting bigger y values as I go to the right. So as I approach infinity, get those higher y values. And when is my graph going down? When am I approaching those very negative y values. That's as I approach 2. When's my x-intercept? Well, we can check out our graph here. It's 2, 3, 4, 5, 6, 7. Looks like 7, 0. But again, we'll check that here in a second. And our asymptote x equals 2. So let's check that y-intercept here. Or not y-intercept, x-intercept. So we can plug in 0 for y. So 0 equals log base 5, x minus 2 minus 1. Now let's add 1, add 1. So what are we looking at here? 1 equals log base 5 of x minus 2. And again, anytime I've got a log equal to a number, write that in exponential form. So 5 to the first equals x minus 2. Or 5 equals x minus 2. So x equals 7. Sure enough, we're pretty good at graphing, it turns out. Which is a nice thing to know. Good to know we're not doing too bad here. And our last one here, graphing just this parent function first. X, y. So log base 1/4 of x. So 1/4 to what power gets me 1? Anything to the 0 power gets me 1. 1/4 to the first power gets me 1/4. 1/4 to the second power gets me 1/16, because 4 squared is 16. And now let's flip our fraction. So 4 over 1. 1/4 to what power gets me 4 over 1? Well, if I flip my fraction, it's negative. 4 to the first is 4. And then we could do the same thing here with 16. We do have, it seems, a couple of transformations. So let's just hold off here for a second on making any big dots. Let's just do small dots only for now. And what are we looking at? 1, 0. 1/4 was 1. 1/16 was 2. That's a very steep curve. 4, 2, 3, 4, negative 1, and then 16, negative 2. I'm not even going to be able to graph that. But what we can do here is, let's check out our transformations. So inside the parentheses, what do I have to do with that? I've got to figure out, what's the opposite of what I think I'd see. So it's going to be a right 1 shift. And here I've got up 1. So right 1 and up 1. All right, what? Let's do this in, let's do this one in orange. So right 1 and up 1. Right 1, up 1. Right 1, up 1. Right 1, up 1. Right 1, up 1. And we shifted right 1. So our asymptote shifted right 1. And let's do our best here to graph this. Again, doesn't need to be perfect. We've got our x-intercept. Looks like it's going to be a nice one. And let's identify some of these key characteristics. Domain shifted right 1, so x is bigger than 1. Range, y, could be any real number. And let me just close that bracket. When is this graph getting very big y values? When is that graph going up? Well, it's going up as I go to the left, as I approach 1. And when is this graph going down? Well, it's going down as I approach infinity, as I go to the right forever. x-intercept looks kind of nice. 1, 2, 3, 4, 5. Looks like I've got a 5, 0, and that asymptote x equals 1. And since this is our last problem, you know what? Let's just do our due diligence and check that x-intercept. So plug in 0 for y, log base 1/4 x minus 1 plus 1. Let's get the log by itself. So we'll minus 1 on both sides. So -1 equals log base 1/4 of x minus 1. And now let's do the only thing we can do is anytime we've got a log equals a number, I'll write this in exponential form. So 1/4 to the negative first equals x minus 1. Anytime I've got a -1 power, we can sort of flip our fraction. 4 equals x minus 1, and sure enough, x is 5. So don't forget your properties of logs. Of course, end behavior is very important. I know that's something that we've touched on earlier in the semester, but I want you guys to again, just get this homework done here. Keep studying, check in with that mini quiz on the Google Classroom, and stay safe. Wash your hands, spend some time with your loved ones, and take this opportunity